सो बेटा आज का जो टॉपिक है हमारा दैट इज called as a missing course or a missing leg topic. This is basically they give you a summary that ship was going from one place to another place. From this time it steered this course, then it steered this course, this course, this course, so on. And one of the legs in between they will not tell you. So they will tell you okay, from this time to this time the course steered is not known. This is a highly unrealistic case. This will not happen practically. You will know what you are steering. But this is to test your understanding of passage planning, plane and parallel sailing, these kind of concepts. So we have to find out what was the course steered by the ship during that interval. So this is what is required. So what we will do is I will show you a question which has come in our past papers on this topic, and we will try to solve it on the chart. So that will give us an idea how it is to be done. The technique what we follow in these questions is, you see our passage plan is basically a combination of vectors. You have the CTS vector, then the current vector, then the next CTS, so on. So all these vectors are combined, and once they are combined, you reach to your destination. Now, vectors can be combined in any order. So if a particular course is missing, you can leave that, you can apply the next one, remaining all the vectors which are known to us. Once they are applied, we are easily able to identify what was the missing course in the end. So let's try to understand it using an example. So shall I open up the presentation? The concept theoretically. Let's try to further understand it using a practical example. So I'm going to pick up a question based on this topic of missing course or missing leg, which has come in our past papers. We will try to plot it on the chart, and we will try to understand the solution practically now. The question says, at 0530 hours, a vessel was in position with Lundy Island south, bearing 030 true, 6 miles off. She steered a certain compass course, and her engine speed was 9 knots. After 1 hour, that is at 0630, she altered her course to due north and increased the engine speed to 12 knots. At 0700 hours, that means after another half an hour, the bearing of Lundy Island North was observed to be 120 degrees true. The current in the area was setting 330 at a rate of 3.5 knots. Find her position at 0700 hours and the initial course steered. This question is based on chart number 5047. So we will just have that part of the chart displayed on the screen here, and we will try to proceed following the method which we just now discussed. So as you can see, they have given us the passage from 0530 to 0700. It's a 1.5 hour passage. And in this passage, they are asking us to find out the course which the vessel steered for the first 1 hour. From 0530 to 0630, she steered a certain compass course, and that is what we need to find. Second thing we need to find is the position at 0700 hours. So let's open up the chart of the area, and let's see how do we proceed ahead and follow the concept which we have learned. We have the area displayed on the screen now. Let's first identify these lights which are mentioned in the question. The light which is highlighted right now on the chart is the Lundy Island South light. Now at 0530, the Lundy Island South light was bearing 030 and it was 6 miles off. So this information basically gives us a position at 0530 hours, a fix. So let's plot this position. You can see the 030 bearing being plotted on the chart. Now on this line with a distance of 6 miles off, 030 bearing and a distance of 6 miles off, if you make an arc with a radius of 6 miles centered at this particular light, the point where the arc cuts this PL, cuts this bearing line, is our position for 0530. So you can see the time which is marked. It is the 0530 position. The bearing and range is also marked here, 030 into 6 miles off. Now, the initial course which the ship steered is not known to us. So we cannot plot the 0530 to 0630 track. But as we just now discussed in the method of vector addition, that whatever information is available to us, we will be plotting that information. So what I'll do is, I will plot the next course information which is available to me. At 0630, she altered her course to due north and the speed was 12 knots. And she steered this particular course and speed for half an hour. So we will plot that on the chart. But before that, let's identify the second light which is given here. The second light which is given here referred in this question is the Lundy Island North light. At 7 o'clock, it was observed to be 120 degrees true. So you can see on the chart, this light which is highlighted is the Lundy Island North light. At 0700, this light was observed to be on 120 bearing. So this gives us a position line for 7 o'clock. So you can see the position line plotted on the chart. And this line is applicable for 0700 hours. The vessel should be somewhere on this line at 7 o'clock. I have marked off the bearing of the lighthouse, which is 120. Now, as I told you that whatever information is available to us, we will be plotting that information. So from 0630, we have steered a course which is due north and our speed was 12 knots. So for half an hour, that is from 0630 to 0700, the distance covered would be 6 miles. So from this point A, which is my initial position at 0530, I'm going to draw this particular course and distance vector. So it will be 000 and the distance would be 6 miles. And it represents the track or the course steered from 6:30 to 7 o'clock. So let's plot this vector starting from point A. You can see this vector plotted on the chart now. The point where this vector ends, let's name that point as Bravo. So this was the information available to us from 6:30 to 7 o'clock, which we have plotted on the chart. Now the next information given to us is the current in the area was setting 330 at 3.5 knots. So this current has affected us for the entire duration of the passage, that is 1.5 hours. So the next thing which I am going to plot from point B now is the current vector for this entire period. The current for this entire period will set us in a direction of 330 as mentioned in the question. And with a speed of 3.5 knots in 1.5 hours time, the drift would be 5.25 miles. So this is the drift from 0530 to 0700. That is for the entire duration of the passage. So let's plot this vector on the chart. The direction is 330 and the distance is 5.25 miles. You can see the vector plotted on the chart now. The point where this current vector ends, that is C point. You can see this point C marked on the plot. Now we know that from 7 o'clock to 7:30 for a period of half an hour, the vessel was moving at a speed of 12 knots. See, you can see at 0630 the course was altered and the engine speed was increased to 12 knots. And till 0700 hours, there was no change in the speed. So from 0530 to 0630, the speed was 9 knots. And this passage from 0530 to 0630 is the unknown passage, which we have to find out. So now we have plotted our track or course steered from 6:30 to 7. We have taken into account the current which is acting in the area. The only thing remaining now is the course steered vector from 5:30 to 6:30. Now we do not know what was the course which we were steering, but we know that the distance steamed, engine distance steamed in this particular interval is 9 nautical miles because the vessel was moving at a speed of 9 knots. So from point C, my CTS vector can go in any direction. I do not know the direction because I do not know my course steered, but I know for sure that the length of my CTS vector has to be 9 nautical miles. I know from 5:30 to 6:30, I covered a distance of 9 nautical miles. So I'm going to use this information. I'm going to open up my compass equal to 9 nautical miles. Place or center that compass on point C and draw an arc. So I'm going to draw an arc. Now this arc is going to cut my 0700 bearing line at a certain point. So let's place our compass at C, which is open equal to a radius of 9 nautical miles, and draw an arc. You can see this arc plotted on the chart here. The point where this arc cuts my 0700 bearing line, let's name that point as D. Now this D point is my fix at 0700. Now, how is this point the fix, the position at 0700? Because you see, the fix has to be 9 miles away from the C point because the distance, engine distance steamed in this particular interval was 9 nautical miles. So this point delta fulfills that requirement. It is 9 nautical miles away from the C point. That is my distance steamed between 5:30 to 6:30. The second condition which it has to fulfill is that at 7 o'clock, my position has to be somewhere on this position line. So this is the only point which fulfills both these conditions. It is 9 miles away from C and it is situated on the 0700 bearing line. So there is no other point which satisfies that criteria. If I place my compass centered at sea, radius equal to 9 nautical miles, and make a full circle, this is the only point which will lie on the 0700 PL, telling me that this is my fix.
सर
गो अहेड बेटा।
सर ये मतलब ये तो समझ में आ गया कि हमने क्या किया है, पर ये कैसे, मतलब हमने पीएल जो ली वो 530 की थी, उस पीएल से जो हमने डिस्टेंस और अपना कोर्स मार्क किया वो 630 टू 700 का था।
राइट।
फिर उसके बाद हमने जो B2C मार्क किया वो 530 टू 700 था। मतलब
दैट इज द करंट बेटा, 530 to 7।
मतलब हाँ जी, मतलब ये जो कर रहे हैं वो समझ में आ रहा है, बट ऐसा क्यों कर रहे हैं ये नहीं समझ में आ रहा। मतलब
ओके
बड़ा अजीब सा हो रहा है। अभी तक जो चार्ट वर्क करते आए हैं। और
ओके बेटा, ओके।
हाँ जी सर।
अभी बेटा प्लॉट कंप्लीट करते हैं पहले। अभी तो हम अबाउट 50% क्वेश्चन हमने कंप्लीट किया है, और इसको कंप्लीट कर लेते हैं। मैं आपको इसका एक्चुअल ट्रैक भी दिखाता हूँ। शिप का जो एक्चुअल ट्रैक है वो ये नहीं है, दिस इज जस्ट ए वेक्टर एडिशन विच वी हैव डन टू फाइंड अवर CTS। अभी हम इसका एक्चुअल ट्रैक भी बनाएंगे, देन होपफुली इट विल
बेसिकली हम
बिकम।
मैथमेटिकली इसको सॉल्व करना चाह रहे हैं विद द चार्ट वर्क।
दैट इज राइट बेटा, दैट इज राइट।
मतलब क्योंकि चार्ट वर्क के हिसाब से तो ये ठीक नहीं है, बट मैथमेटिकली हाँ ये ठीक होएगा ऑब्वियसली, क्योंकि डिस्टेंस और कोर्स आगे पीछे लें चाहे जैसे मर्जी लें, आना तो आंसर फिक्स 700 का वही है।
एग्जैक्टली बेटा, दैट इज द प्रिंसिपल विच वी आर यूजिंग, दैट इज एग्जैक्टली राइट।
ठीक है सर।
हाँ, अभी मैं आपको इसका एक्चुअल ट्रैक भी बना के दिखाता हूँ।
ठीक है।
ओके
So we have found out our 7 o'clock position. Now what I'm going to do is I'm going to join these 2 points, C and D, Charlie and Delta. Now this line CD basically represent my CTS vector from 0530 to 0630. This is the course to steer vector from 0530 to 0630. Because all the vectors added up should take me to my final position. So we can align our parallel ruler with CD, take it to a compass rose and read out. This is the course steered by the ship from 0530 to 0630. This is the true course steered. Now, if you want to find out the compass course steered, you have to apply the compass error, the deviation and the variation, and it will give you the
सर
compass course steered.
सर
गो अहेड बेटा।
सर फिर तो अगर ये जो अब CTS आ गया, अगर हम इसको अगर वो फिक्स है सही, तो हम इस CTS को इनिशियल पोजीशन पे फिक्स करके ट्रांसफर करके देन उस पे ये नदरली कोर्स मार के करंट मारेंगे तो वो वही आएगा सर, वही आना
एग्जैक्टली
चाहिए।
बेटा, एग्जैक्टली। अभी मैं यही आपको करके दिखाता हूँ। जो ये हमें मिला है अभी ना CTS, हम इसको अपनी इनिशियल पोजीशन पे लगाते हैं, एंड देन वी विल सी वेदर वी रीच बैक एट 7 o'clock पोजीशन और नॉट।
ओके सर।
Okay, so we will see the actual track now.
So we have obtained what was required in the question. Find her position at 0700 hours and the initial course steered. Both the items have been obtained. Now, once this much is done, one important thing to remember here is that this track which we are seeing on our plot, starting from A, that is my initial position, going to B, then B to C, and C to D. This is not the actual track followed by the ship. Why it is not the actual track? Because the first vector which we have placed here, 0630 to 0700, that is north with a distance of 6 miles, is not the first course which the vessel steered. It is the course steered from 6:30 onwards. The first course which the vessel steered is CD, Charlie Delta. So to find out the actual track of the ship, we have to now plot our courses and distances in the correct chronological order. So let us now plot our courses and distances as they actually happened. So it is not asked in the question here, but it is a very good idea to plot it on the chart. So in some of the question, this may be required also by the paper setter. He may ask you to give you the actual position of the ship at 6:30 or any intermediate point. So for that, you will need to draw the actual track of the ship. So let's now plot the actual track of the ship. I know my course steered from the direction of the CD vector now. This is the course steered from 0530 to 0630. So from point A, the first vector which I draw now is same as vector Charlie Delta. So this is the course steered from 0530 to 0630. Let's mark it with a single arrow. That is the symbol of the course steered. Now the point where it ends, let's name that point as eco point, E point. Now let's apply the current also for the first hour. I have the set of the current 330. I have the rate of the current also, which is 3.5 knots. So from point E, I apply my current vector. Now be careful, this current vector is for 1 hour duration now, because my CTS vector is also for 1 hour duration. I am making a 1 hour triangle in the beginning. So let's mark it with 3 arrows, the symbol for current vector. Now once this current vector is plotted, the point where it ends, let's name that point as F. F is our fix at 0630. And if you join my initial position A with the fix here at F, it gives me the course made good from 0530 to 0630. This is the actual track on which the ship moved from 5:30 to 6:30. Now, one important difference here is you see the current vector which I used in this diagram is for 1 hour. The current vector which I had used in my initial plot was for the full duration of 1.5 hours. Okay, that's the difference. Even when you use it for total 1.5 hours, we were still able to reach to our destination because, as we discussed before, the principle of vector addition says that in whatever orders the vectors are added up, the end result or the position arrived is the same. So let's now proceed ahead from point F. The next course which I steered from 6:30 to 7 o'clock was 000, and the distance was 6 miles, represented by vector AB. So I have plotted this vector here, which is my CTS from 6:30 to 7 o'clock. And the point where it ends, let's mark it as G. And this vector here, the blue color vector, the CTS vector, has a direction of due north 000 and has a length of 6 nautical miles, exactly same to vector AB. Now from the point G, where my CTS vector ends, I now plot my current vector for half an hour, that is 6:30 to 7:30. This triangle which is being made is for half an hour. Let's plot the 3 arrows for the current vector, and it will take us to our 7 o'clock position. You will see that when you plot this current vector, it takes you to the exactly same position, the 7 o'clock position which we earlier found out. Now, if you join F with the final position delta, This gives me my course made good from 0630 to 0700. So you can see the actual track followed by the ship from 5:30 to 6:30. This is the 6:30 position, and from 6:30 to 7 o'clock, and this is the 7 o'clock position. So this completes our missing course or missing leg question.
812 Hookhead Lighthouse bore this much, Connenberg light vessel bore this much, vessel then steamed a course of 182, maintaining same course, lighthouse dips at 1014. Right, there were two position circles here. एक तो ये HSA से आया है पोजीशन सर्कल, और दूसरा पोजीशन सर्कल डिपिंग रेंज से आया है. सो दे आर इंटरसेक्टिंग एंड द इंटरसेक्शन पॉइंट इज द फिक्स. इसमें क्या डाउट है बेटा?
सर ये जो इंटरसेक्शन हुआ है सर, ये तो दूसरी साइड बनेगा ना?
मींस हियर बेटा एट दिस लोकेशन?
नो, दैट इंटरसेक्शन फ्रॉम जहां से ये 190 स्टार्ट किया आपने, ये कॉननबर्ग लाइट वेसल से, ये वाला उस साइड बनेगा ना? ओके सर, मेरी गलती है सर, मैंने उस साइड बना दिया इसको. द इंटरसेक्शन.
Intersection means you made the circle on this side?
Yes sir, yes sir.
ओके. इसमें बेटा अगर आपको डाउट होता है ना कि शिप कौन सी साइड में है, बिकॉज यू सी इट ऑल डिपेंड्स अपॉन कि शिप कौन सी साइड में है. यहाँ पे जो आपका हॉरिजॉन्टल एंगल है आई थिंक इज ग्रेटर देन 90, या इट इज 128.
Yes sir.
So you have to make it, the center has to be made opposite to the side where the ship is. Correct?
Yes.
तो अब ये कैसे पता चलेगा कि शिप कहाँ पे है? बिकॉज इस केस में तो दोनों तरफ ही नेविगेबल वाटर है. तो ऐसे केस में बेटा आप क्या करो, जो कंपास बियरिंग्स है ना, उनको रफली अपने चार्ट पे ड्रॉ करके देखो. When you draw the compass bearing, you will get an idea whether the ship is on this side or on this side. Then you can pick up your center.
Okay sir.
Okay?
Okay sir.
Right, beta. Right. Okay.